Hello and welcome. In this video, we're going to be talking about solving trigonometric equations that involve double and triple angles. Now, what do I mean by that? Instead of solving things that look like sine x equals a half, instead we're going to modify them so they look a little bit more like this one down here with a sine 2x or a cos 2x or something like that, okay? Now, it relies on a lot of the same skills that we've covered in solving basic trig equations. So you're going to see us use a lot of those again. Okay. However, when we have an equation with a double angle, such as the sine 2x, we can think of it as doing two revolutions around the circle. Okay. So instead of solving for just one revolution, okay, which is 0 to 360 degrees, what we're going to do is we're going to search around our circle again and collect an extra set of results. Now, if we do sine 3x, we're going to go around 3 times. That's essentially what's happening. I'm going to explain to you a little bit as to why that happens, and it's to do sort of with the domain of your function, the domain of your equation that you're talking about. Now, the most important thing to remember is to remember to adjust your angles, so these will be the solutions that pop out at the end, so that they're in the correct domain when you're solving, okay? So, first example, solve sine 2x equals a half for 0 to 360 degrees. Now, that's actually really, really easy for us to do, and it actually doesn't modify our original method of solving basic trigonometric equations too much, okay? So here's what's going to happen, all right? First things first, we want to find our first angle in our rotation, right? We call this our base angle. So step one, we're going to find our base angle. Now, the easiest way to do this, right, is just take the inverse sine of whatever you have on the right-hand side of the equation, okay? So to do that, we're going to do inverse sine of a half. We ignore the sign, okay? We don't care whether it's negative or positive, okay? And what that's going to give us is 30 degrees on our calculator, okay? The next thing that we have to do is we need to identify the quadrants and angles, just like what we were doing when we were doing basic equations, okay? We want to identify our quadrants and angles when we're doing this. All right, so that's basically where we draw our all stations to central. All right, this is just a quick little sketch to make sure that we are just helped in terms of our visual understanding as we go around. So all stations to central. Now, notice here that our answer is positive. So that means wherever sine is positive, that's the quadrant that we're going to be in. So that means we're going to be in all and we're going to be in sine, these two things. Now, we found our original base angle, our base angle of 30 degrees. Okay, so we know from the horizontal, each of our angles that we measure, okay, is going to be 30 degrees. Just like in our base angles, remember that we measure from the positive x-axis anti-clockwise, okay? So our first angle here is going to be 30 degrees, and then our second angle that we encounter is going to be 150 degrees because it's 180 degrees minus our 30, going back in the opposite direction, okay? As you can see, that's just going back in the opposite direction just there. Now, normally, we would pretty much have our solution. We would go x equals 30 degrees and 150 degrees, and we would stop there. However, you might notice that I've written a 2x here. Now, this 2x relates to the 2x inside of our trigonometric equation. I'm going to explain to you in just a minute why that's really, really, really important, because it's to do with this here, okay? All right. However, I also mentioned to you that this is like us going around the circle twice because we're multiplying our frequency, and you're going to see this word pop up a lot. We're multiplying our frequency to have it occur double the amount of times, okay? So what we're going to do is we're going to go around our circle again, okay? So we're going to continue around until we get back to this 30 degrees. Now, essentially what we've done is we've done 360 degrees plus whatever our 30 degrees is going to be. Okay, so that's going to be our next solution because we're going to hit that same quadrant again. Remember, we're just going around the circle, so the solutions will repeat. And the same thing is going to happen one more time if I repeat it and go all the way around to 150 degrees. So now we're going to have our 360 degrees plus our 150 degrees, okay? All right, so tidying this up a little bit, okay, we'll just simplify this down. We'll have 2x is now equal to 30 degrees, 150 degrees, 390 degrees, because that's 360 plus 30. And then we end up with, my apologies, we end up with 510 degrees. Okay, there are our four solutions that we have pop up. Now, just remember, this happens because we are mechanically going around the unit circle 2 times, okay? That's what's caused by this 2x here, okay? All right, so all of the other steps have been very, 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 very similar, all right? However, you'll notice that we're only solving for any angles that occur between 0 and 360 degrees. Now, that's a problem, okay? Because you'll notice some of our angles down here, okay, are above 360 degrees. Well, that's where this 2x comes in. Just like what we would solve with a normal x equals, all right, and put our angles out, all right? Now we're solving with a 2x equals. So we want to get our x by itself, okay? So what we're going to do is we're going to divide everything by 2, and we have now x now equals 15 degrees, 75 degrees, 195 degrees, and 255 degrees. And these are actually our final answers. But I want to explain a little bit more as to why this actually occurs, okay? All right, why are we going around the unit circle twice when we're finding our solutions? Well, it comes back down to this domain where I've got lots of arrows here, okay? What this domain talks about is anything being a solution between 0 and 360 degrees. However, notice inside of this particular equation, we have a 2x, but in here we have an x. Well, this relates to what's called the frequency of your trigonometric function, okay? Now, if we're doubling the frequency, whatever's inside of that equation, essentially we have to make match inside of our domain to understand how far we're going to be searching, okay? So if I double this 2x, what I do to one thing in my inequality, I have to do to everything else, okay? So you'll notice that I've also doubled the 360, and when I double 0, I get 0 back. So what we're doing is we're searching for answers, right, as we go around and around and around and around our unit circle twice for everything between 0 degrees and 720, which is why we end up with the 4 solutions when we're doing this algebraically. Now, graphically, what does this mean? Okay, well, whenever I solve, whenever I graph sine 2x, it just means essentially that my graph has occurred twice in the same space, okay? So I might show you graphically what's happening here, all right? Normally, we would have one sine curve occur here from 0 to 360 degrees out here at the end. However, you'll notice that the sine curve goes up and down twice inside that same range, which means that when I put a line through a half, which is what we're doing, sine 2x equal to a half, which just means that I'm solving where is my sine 2x, my graph of y equals sine 2x, equal to the y value of a half, okay? Which is this line going along here. And now that's exactly what we're looking at. And you'll notice that we have the same answer that occur. Here at 15 degrees, here again at 75 degrees, again at 195, and again at 255 degrees. Essentially, what we're doing is we're just finding the solutions when our trigonometric function goes up and down twice in the same domain, okay? So the important things that I want you to take away from this example, okay, is one, find your base angle, the exact same as what we're doing when we do our basic equations. Identify your quadrants, okay? However, be very, very careful when you're finding your solutions because you need to remember to have a 2x or a 3x if that's what's in front of the value, okay? And remember that you're going to have to divide by that same value when you're finding your final answer, okay? So just be very, very careful. So let's do one more example before we head off, just to make sure we can concrete our understanding of it, and then we'll move on. Okay, so in our next example that we're going to do here, we're going to do essentially the same style of question, okay? So here we're solving cos 2x equal to 1 on root 2. And because we have a 2x, remember, we're expecting us to go around the unit circle twice, so we're expecting double the amount of solutions, okay? Because we're doing 2 revolutions, all right? Because we're doing that, remember, we need to search for our solutions in a different domain. Our final answers will all be between 0 and 360, but instead of it being between 0 and 360 degrees for where we expect our solutions to be, instead, we're going to search all the way from 0 degrees. Remember, this is just a normal x. Because we have a 2x over here, we want a 2x inside of this inequality. All right, so we're searching for our solutions between 0 and 720 degrees, okay? So we can expect double the amount of solutions, okay? So Number one, we're going to find our base angle. Okay, so to find our base angle, we do inverse cos of the right-hand side of the equation. Using your exact value triangles, okay, you'll know that'll pop out to be 45 degrees. Next thing that we want to do is we want to identify the quadrants that we're working in. Notice that I'm working a little bit quicker now without as much detail. Let me just fix that line up. Okay, now this is because some of these equations can get very, very long, all right, when we're solving them, particularly when we get to our next skill, which is solving quadratics, all right? And I'm still trying to convey as much detail to the marker as I can in terms of my understanding, all right, while not taking forever while doing a question, okay? So next, we want to identify what quadrants we're in. Well, we look here and we notice the right-hand side of the equation is positive. So what we're looking for is wherever cos is positive, okay? And cos is positive here and here in the first and fourth quadrants. Okay, so using our base angle, we're going to have 45 degrees, and we're also going to have 45 degrees. Always measuring from the horizontal, okay? All right, so what we're going to do, remember we're doing 2 revolutions, okay? So our final answer is going to have 2x equals, well, our first solution measuring from the positive x-axis anti-clockwise is going to be 45 degrees. Okay, then going around a little bit further, we're going to have 360 coming back for 45 degrees will be 315 degrees. All right, so they're our first 2, and they're our first revolution. Now, what we can do to find our next solutions, right, is essentially what we're going to be doing is we're going to be taking another full revolution of the circle around. Okay, so we can take whatever answer we have in our first revolution and we can just add 360 to it. So 45 degrees plus 360 degrees. And then we have 315 degrees plus 360 degrees. Now, what that is doing, okay, is making sure that we just hit our second solutions, because the solutions are going to be in the same place on our curve as we travel around the unit circle multiple times. Okay, so simplify that up a little bit. Okay, so we have 2x now is equal to 45 degrees, 315 degrees, 405 degrees, and finally 675 degrees. But remember, okay, we want all of these solutions to be between 0 and 360 degrees. We want them to be between those, and they're not at the moment. Okay, remember we were just searching between 0 and 720. The way that we do that is we're going to get the x by itself. We're going to divide both sides by 2. So x is now equal to, and it's really, really important that you remember to do that. Heed my words. Okay, 22.5 degrees, 157.5 degrees, 202.5 degrees, and finally 337.5 degrees. Okay, which makes sense. Okay, we've gone around the circle twice. We're expecting double the number of solutions. All right, going down a little bit further. All right, we might look at this visually in terms of what's happening. Okay, you'll notice here that our first solution occurs here at 22.5. Our next solution occurs here at 157.5 degrees, again at 202.5, and then again at 337.5, right? When we're finding the intersection with the line y equals 1 on root 2, right? When we're graphing y equals cos of 2x, okay? It makes sense because our cos curve is now going up and down twice the amount of times inside of the 360 degree space, okay? All right, so really, really important to sort of remember everything that we're doing. Just as a summary, first things first, identify what domain you're searching for, so that's 0 to 720, all right? Find your base angle next, identify your quadrants, and remember at the very, very end that you want to divide by the number of revolutions that you're doing to find your final answers, okay? Just be very, very careful when you're doing this. Now, if I was to do a triple angle result, for example, with a sine 3x, we do all of the same things except we go around 3 times, okay? All right, everything behaves the same. Instead of this just being a 3x, a 2x, then this would become a 3x, and we perform exactly the same things, because it just means instead of it just going around twice, we're going around the unit circle 3 times when we're finding our solutions. Okay, I hope this has been beneficial. Thank you very much.